Welcome viewers. We continue with our lesson from where we ended. Last time we discussed on the calculations in series. So today we're going to focus calculations in parallel. So in physics, last time we said whenever we're doing calculations under series, we said there are some three basic principles which you need to understand. Once you understand those three basic principles, it means that the work is easy. Same in parallel. In parallel as well, we'll discuss on the first three principles which can help us to understand how the calculations must be done. Once we know that, then the work will be easy. Therefore, the circle diagram which we saw in the other video will differ from the one we're going to do today. Then after we do the series and then the parallel individually, then we'll do a combined one, which will make now our work to be easy once we all provide that the principles in both parallel and in series are well understood. So shall we continue now? We'll do this. So this is a simple circuit diagram. So this circuit diagram will have two resistors in parallel. So this resistor and this resistor. So we can call this one as resistor 1, then this one as resistor 2. And let's put an ammeter here which measures the amount of current passing through a circuit. So here we have the source of voltage. The principles which I was talking about, number one, we need to understand that voltage in parallel is equal. So voltage in parallel is equal, meaning that the resistors which are in parallel, their sum of the voltage will be equal. Then the second one will be the current in parallel is different. Provided the resistance is not the same. Then the third one, which helps us to predict the outcome of the voltage, we'll say, or the resistance. The more the resistors in a circuit, the more the resistors in a circuit, the lower the current, the lower the resistance, not current. So those are the three principles which we need to understand whenever we're doing calculations in parallel. Therefore, after looking at these principles, we can now go direct into calculations so that we can see how these principles can be applied. So, where's my duster? Okay, so let's remove this. Hope you have understood. So it means that the higher the resistance, the lower the current. Resistance is inversely proportional to current. So if you increase current, we're expecting resistance to reduce and vice versa. Then the voltage which is in parallel, so the voltage which is passing between these two resistors is equal. So the amount of voltage this one resistor is using and this one is equal. But the current in these two resistors will differ provided their resistance is different. But if the resistor here has two resistors, here has 2 ohms, so 2 and 2 will all share the same amount of current. But if the resistance is different, it means that even the current will differ. So let's say we have 3 ohms here, then we also have 6 ohms here. Then let's put here, let's get let's get 8 volts now. Then the first question is, we need to calculate the total resistance in series. So total resistance is given by this formula, 1 over RT is equal to 1 over R1 plus 1 over R2. So this is the formula, so we have these two because we have 2 resistors. Therefore, you can say 1 over 3 ohms plus 1 over 6 ohms. Of course, mathematics, we know that when you have a fraction, you have to find the common denominator. So the common denominator now, if the smaller number can go into the bigger number, it means the bigger number is the common denominator. So put 6 here, 3 into 6 will give us 2, 2 times 1, it will give us same 2. So 2 ohms plus 6 into 6, 1 times 1, we have the same one. So 2 plus 1, we're expecting to have 3 ohms over 6. So we have simplified here, then we can bring down this part here. So let me say this part, 1 over RT is equal to, we had 3 over 6. So a cross multiply, so 3 by RT, we're going to get 3 RT, which is equal to 1 by 6, 6, then divide by 3, divide by 3, so we cancel out. So RT is here, 3 into 6, we are getting 2 ohms. Second principle, or the third principle, the more the resistance which we have in the circuit, once we find the total resistance for this, so these will give us 2, but here you have 3, here you have 6. So if we add another resistor, we're expecting this number to reduce. The higher the resistance, the lower the resistance, and vice versa. So this is how we find the total resistance. If you're dealing with paper 2, you need to show this work for the sake of gaining more marks. But for section A, we have been given this one to find total current, where 1 mark is our date. Don't even waste time to come up with these things. Just go to the direct shortcut, the formula for effective resistance. The formula for effective resistance, we know that effective resistance is equal to R1 plus R2. So we divide by R1 plus R2. So we have 3 times 6, of course, I'm not putting units, then 3, so 3 by 6, then you have 3 plus 6. So I'm getting 18, I'm getting 9, 9 into 18, I'm getting 2 ohms. So same answers, but different formula. Now, this one, when they are not asking you to find effective resistance, don't use this formula. Come up with this formula so that you gain more marks. For the sake of section A, which comprises the multiple choices, so you need to understand that that one has multiple choice. So you can use this one, you can work on this one on the separate part, then you again find the current which the question is demanding you to answer. So no need to come up with this, you're wasting time, exam waste time. Alright, so having looked at this one, now you can talk about what we call current. So current, this is our answer, I'll leave it here. Current, according to Ohm's law, we said Ohm's law states that the current passing through a conductor is directly proportional to PD, or potential difference, or voltage between 2 points, provided other conditions remains constant. In symbols, we are saying resistance is equal to voltage over current. So we are we have the total voltage, we can find the total current. Therefore, wholesale voltage, we have 8 volts. Don't forget to put units whenever doing calculations in sciences. Then we have these 2 ohms. So 2 into 8, we're getting 4 volts. So this, not 4 volts, 4 amps. This is the current which was passing through the circuit. So this current, when it's coming in this direction, it will be detected by the ammeter here, then to come at this junction. The current at this junction is equal to the current at this junction, meaning that the resistor with higher resistance, it will have low amount of current passing through it, and the one which has low resistance will have higher current. Therefore, we will now look at it, how much current was passing here and how much current was passing there. So we cannot predict to say, since we have 4 as the total current, therefore here it can pass 4 or it can pass 1 or 3. No, we need to do the calculations. Therefore, current is equal to voltage over resistance. Remember, whenever I'm making the subjects or the formula, when you have an equation like this one, these two, they just interchange and you maintain the number or the letter on top without being changed. So current 1 with this resistor 1 here. So we have voltage. Remember, voltage in parallel is always equal, so you get 8. So from here, we'll say 8 volts. Okay, let me move my current here. So current, we had 4. So this is our data. So 8 volts over, what do we have? We have here, we have 6 ohms. We have 6 ohms. So when we do the calculations, what are we getting? So 2 here, we're getting 4, 2 here, we're getting 3, 3 into 4, we're getting 1. Remainder 1, then put a point, 0, 3 into 10, we're getting 3. Again, the remainder 1, so like that, it will continue. So here, the first one, we have 1.33 amps. Okay, now for the second one, okay, we have removed this one. So for the second one, we'll say current again is equal to voltage over resistance. So this is now the current 2, which is representing resistor 2. So voltage same. So 8 volts over, we have 3 ohms. So 3 into 8, we are getting 2, remainder 6, plus 2 to give us 8, so remainder is 2. So put a point, add a 0, then 2 into 20, we're expecting to get something like 2 into 20, it's what? 3 into 20, expecting to get 18, expecting to get 6. Okay, so 6, remainder 2, so again 6 to go like that. Therefore, we have this as our current 2. So the lower the resistance, at least the current is higher compared to this high resistance, the current is lower. So if you had 1.33 plus 2.66, we need to get, which we found, 4 amps. So that is how we find current in series. In parallel. 1, you need to know to find the total current. Then after finding the total current, you can also find the amount of current which was passing through it in individual resistor. Therefore, for today, we end there. Now, next time, we'll look at how we can calculate current, voltage in each resistor in a combined circuit. So having known how to find that one, we can also now talk about a combined resistance and find the current sometime. So for today, we end here. Feel free to ask questions in the comment section below. Remember, we offer sciences, we offer mathematics, English, biology, and other options like civic education and RA. So for today, we end here. Next time we meet, we'll meet using now the other type of a circuit.